if you want to build models, if you want to build artificial intelligence systems, all of those systems need to be powered by access to highly accurate, highly clean, quote unquote, ground truth data, right? If you're going to train the model off of lots of examples, you want those examples to be accurate and correct.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. Today on the show, I'm going to be talking to Ryan Fox Squire. He comes to us from a company called SafeGraph, and we're going to have a conversation around points of interest datasets, how you ground truth them, and how you even create these datasets at a massive scale. It's an interesting discussion, and I really hope you enjoy it. Just before we dive into the conversation today, I want to take a second just to mention our sponsor. That's Hive Mapper. Hive as in Beehive Mapper, and this is the platform that lets you upload video footage to the cloud and have it automatically converted into usable 3D geospatial data layers. Okay, let's get into it. Hi Ryan, welcome to the show. Thanks so much for taking the time to do this interview with me. We're in different time zones, so I really appreciate this, that we've managed to work it out. You work for a company called SafeGraph, and unless I'm mistaken, you make ground truth datasets of the physical world. So this sounds like it's got a lot to do with geospatial. But before we dive into all that stuff, can you maybe just give myself and the listeners a brief overview of your background and how you got involved in this work?
Sure. Thanks, Daniel. And yeah, pleasure to be here. So I have a science background. I went to graduate school, do a PhD in neuroscience, actually. And during my time at grad school, I realized that what I enjoyed the most was working with data, communicating about data. And there were just so many great opportunities to do that sort of stuff outside of academia. And so I've been working in data science and product roles at technology startups for the last 7 years or so. And the reason I got into geospatial data was because of SafeGraph. Like you said, SafeGraph is a geospatial data company with a key focus on building data sets about places in the physical world. And that sort of was my doorway into the GIS world.
Okay, so we're building data sets about the physical world, and at the start I mentioned something about ground truth data sets. Can you put a few more words around that? What is a ground truth data set?
Absolutely. So the concept of ground truth sort of comes from, machine learning world. If you want to build models, if you want to build artificial intelligence systems, all of those systems need to be powered by access to highly accurate, highly clean, quote unquote, ground truth data, right? If you're going to train the model off of lots of examples, you want those examples to be accurate and correct. And so that's sort of the broadly the problem that SafeGraph is trying to solve, which is how do I get good data about the physical world? Happy to talk more about that, but that's sort of the high level summary.
Cool. Yeah. So maybe we could talk about how we get data of the physical world. That'd be a great place to start, because I'm assuming you don't that this is not something that already exists. You go and make it out of presumably a whole bunch of other data sets. Maybe you derive some data based on these other data sets that you're gathering together. Can you give us a little bit of a sense of how this is made, perhaps that some of the data sources that you use or integrate?
Absolutely, yeah. So SafeGraph, the GIS data world is obviously a big world, and so SafeGraph is really focused specifically on understanding sort of places or points of interest in the physical world where people can spend time or spend money. And in particular, we're focused on these sort of commercial points of interest in the United States and in Canada. So these are all of the retail places, all of the restaurants, movie theaters, hotels, golf courses, all these places where consumers might go and spend time or spend money. And so then the question is, okay, where do we get data about those places? And the answer is a lot of different places. So half the battle is figuring out the sourcing of this data and where can we get information about these places that we think will be valuable to our end users. So, for example, we do a lot of crawling and scraping of data off of the internet, right? These days, all these businesses are putting information about themselves up on their own web pages, up on the internet, and so a big portion of that data comes from sort of intelligently trying to crawl and explore the internet to find data about places. And there's, that's a multifaceted sort of problem with turns out to be a lot of complexity around how to do that in a way that's scalable. And it's easy to be able to crawl that will crawl a single website for a single restaurant. it's much more harder to build a system that will crawl hundreds of thousands of websites, things like that.
Yeah, I could imagine something like perhaps Google Places. That would be a very structured place to begin to find some of these points of interest, perhaps. But not everyone is on Google Places, for example. So there must be a lot of aggregation of data that happens in the background from websites, and I'm assuming councils or maybe other sort of local government organizations are also providing a bit of data to help solve these problems.
Yeah, that's definitely right. Government sources are another major source of data at the city level, at the county level, at the state and federal level. They're all of these different organizations keep records about licensed businesses, and a lot of data about those businesses, like things like what are there's geospatial information about those places. There's category information about those places. So that's another big source of data that we use to put together these data sets. And we haven't talked yet sort of exactly what the data sets really constitute, but government sources are definitely a major source that come into our product.
Yeah, so maybe you could actually give us a bit of a rundown of what this data set looks like. So I'm assuming there's a polygon, if we're representing a building, for example. So let's start with that. We have a polygon, we have a shape. Where does that come from? And then perhaps we could jump into some of the attributes, and you could walk us through some of the perhaps more interesting attributes about this data set.
Sure. So from the SafeGraph point of view, we actually start with sort of the concept of a POI, abstractly. We're trying to find what are all these points of interest or POI that exist out there, and that to start, those things are defined with sort of basic metadata like the name of that place, the address, things like that. Then a big part of that data set that we put together is, like you said, having understanding the sort of geospatial coordinates and geospatial shape of those businesses in the physical world. We often get those two different parts of the picture from different sources, and a big part of what we do is match those data sets together. So for example, we might get information about a place's name and street address from scraping their website on the internet, but their website doesn't necessarily tell you any geospatial information about that place other than sort of the physical the street address. So we also have many other sources that we're collecting to get that sort of geospatial polygon data. For example, right, as we mentioned, the city government might keep records of the sort of building layouts and property layouts of different structures that we can get. Sometimes those data are correctly labeled with the right addresses and the right business names. Sometimes they're not at all. And so a big part of what we do is join these data sets together to try to give you a complete sort of picture of, okay, here's this business, here's its name, here's its address, and here's its geospatial coordinates.
Okay, so I think probably we all understand now that we're aggregating data from a whole bunch of different sources together to make this data set. Um, I guess the big question for me here is what do you do, or how do you solve the problem of we've got, let's say we've got two different data sets and they're saying different things. How do I know which is right? How do I validate that? And how do I validate things like that at scale?
Yeah, that's definitely one of the hard problems that we are excited to be solving for our clients, right? Like, the sort of value proposition to our clients is, yes, like you could go spend a lot of time and money to build this data set yourself, right? In many cases, these data sets ultimately come from public and open sources, but it's actually a quite a large effort to put these things together, to join these things together and to validate. When you get conflicting information, how do you know which is correct, right? Like we have source A that tells us that this coffee shop is at 555 Main Street, and another source says it's 557 Main Street. So how do we decide what's correct? And there's a couple different ways that we approach that. So one way that I think makes sense is that often we're getting data from not just two sources, but maybe five or 10 or a dozen sources. And if it's the case that 11 out of those 12 sources say that it's 555 and one of them says it's 557, we think that's like good evidence that the address is probably 555. So there's you can sort of imagine like a voting sort of system in which we're looking at many different sources and trying to trust sort of what is the consensus. So that's one approach. Another approach is that we essentially have come to understand certain types of sources are more accurate than others. So if we have conflicting sources and one of those sources is that that restaurant's personal website, that personal business's website, and another source is some public review forum or something like that, we're going to trust the restaurant's personal business website over that public review forum, if those are the only two points of data that we have.
It sounds like you're starting to solve some of the same sort of problems that Google has, I think, when they're trying to give the best search result. So it sounds like you're using a voting system, where it quickly becomes a numbers game. If 20 say yes and one says no, then perhaps it's that's a good reason to believe that it's yes. And you're also using a weighting system, so maybe giving more weight to, like you're saying, a personal website or something that you can see that's more directly connected to the object or to this building, for example.
Yeah, that's exactly right.
So maybe we could we could take a little look at the data. Well, we can't do this on a podcast, but perhaps you could tell me about some of the attributes that are inside this data set, because we have a polygon and we have a whole bunch of other things. Can you talk us through that?
So we think about our products sort of in three categories. We really offer three different types of products about points of interest, and we call those products core places, geometries, and patterns. And each of those different products are all keyed on the concept of a place, right? So the primary key is a unique place identifier in each data set, but each data set has different columns that are relevant, and you can easily join those data sets together based on this primary key. But often, depending on your use case, you may or may not want all of those different products. So the core places product is sort of just your essential metadata about that place, its name, its address, city, state, zip. We have category information about that place based on the North American Industry Classification System, the NAICS code. And we have some other metadata like the operating hours of that business, things like that. So there's not necessarily a lot of geospatial data in that data set, but maybe you don't care about that for your use case. Then we have the geometry data set, which includes all the core geospatial data about that place. And so we have both a sort of a point data, latitude, longitude point of where we think that business is in latitude, longitude space. And then we have the polygon, which is, sort of the full building shape that we believe that business, resides in. And then we have some other information to help make that data more useful. These are getting kind of into the weeds, but for example, we have flags that tell you things about is this business inside another building? Is this a standalone place? Does this business potentially share a polygon with another business in our data set? Depending on your use case, you might care a lot about that. And so there's some other sort of other flags that we include to try to make that geospatial data as useful and as context rich as possible. And then the third data set, which is what we call patterns, is a little bit different. It's a summary of human movement dynamics around these places. And so this is essentially a data set about foot traffic in and around these businesses. And that sort of adds a whole other rich dimension to your picture of this business, because now you can see things like, in aggregate, how many people are coming to visit this business? What times of day do people visit this business? What days of the week do people visit this business? When people visit, how far are they traveling to get there? What other places do they go to? And things like that. So that gives you a sort of a rich picture about sort of consumer behavior around these places.
Yeah, it sounds like an absolutely amazing data set. And it's really interesting that you've broken it up into those three different categories of data. Obviously, they can all be linked together through that primary key that you talked about, but offering them as three different data products. Could you give us a use case for this? Let's go with the geometry. So let's what are typical users doing with this data? I come to you and I'd like to have all the business geometries.
Definitely. So the main customers of our geometry data tend to be in like one of two categories. So the first category is we work with a lot of geospatial analytics software companies, including some very large companies. For example, one of our deep partners that we've worked with a lot is the company Esri, and Esri, right, is this incredible, powerful software suite that lets you do all these amazing geospatial analytics. And in many cases, Esri has done an incredible job sourcing and pulling together their own data sets to make available to you inside the Esri platform. But we've partnered with Esri to provide sort of take their POI data sets to the next level, so that when you're working in Esri and maybe you want to have a base map that shows where all the points of interest are, Safegraph data can now power that inside Esri, so that that data is sort of natively available to all Esri users. So that's sort of a class of customers that we have, are these geospatial sort of mapping software companies that want to be able to show POI on a map to their end users, and so they can use our data for that, either with points or as polygons. So that's like one good example.
So typically, when people think about a company like yours collecting, aggregating this kind of data and creating this kind of data products, I think that the fear, or perhaps the assumption, is someone's tracking me again, and they're going to use this data. They're going to track my movements against this data set. Do you see a lot of this? The use cases around your data and what you're doing used in the ad tech industry?
Definitely, ad tech's definitely another large another large segment that we sell to. For example, as you mentioned, there's a lot of interest these days. I think sort of both a lot of innovation and a lot of sort of concern and controversy happening around location-based advertising. And one of the ways that works is, let's say you're like a brand, like let's say you're Target or you're Starbucks, and you have an app that your users use, like the Starbucks app. It might be useful for Starbucks inside that app to be able to send you notifications or send you advertisements or coupons based on whether you're close to a Starbucks or close to a competitor. So those kind of use cases are very common, and definitely another large area that we sell to. And I would say that sort of the common use case in that context is, for whatever reason, the advertiser has access to some location data about their users, and they want to deliver some sort of location context based advertisement to that user.
Yeah, and I can completely understand why they want to do this. Absolutely, but I think that the fear on the consumer side is this idea of being tracked all the time, and perhaps being overwhelmed with push notifications. Although I am hopeful. I am hopeful. I don't see a way around this being tracked, and I don't want to dwell too much on the problem. But I'm hoping that people take these data sets like what you're creating, and create some really positive experiences for users out there, instead of just constantly hammering them with advertising. So I really look forward to see the different use cases which come out of this, especially once the industry starts to sort of mature, and I think look beyond the sort of borders of advertising. When we're talking about geometries and the relationships between geometries, we talked a little bit about spatial hierarchy. So perhaps an example of this might be having a shopping center and then having individual retail spaces in the shopping center. That sounds like a really difficult relationship to define when we're talking about geometries. Can you talk a little bit about how you solve that problem?
Definitely, it is a hard problem. So there's a couple different ways we've approached this, and because a lot of customers of Safegraph data work in sort of retail analytics or retail marketing, and so they care a lot about malls, and they care a lot about all these major brands that often exist in malls. So it's definitely an area that our customers care a lot about, and that we've spent a lot of time trying to work on. And it's a multifaceted solution. So one thing is that we can do a variety of bottom-up sort of detections to try to understand whether places are part of malls or part of strip malls, and things like that give you clues, or when a lot of businesses share addresses, or share sort of top-level addresses. Another thing that we've done is we've sort of manually gone out to figure out, okay, what are all of the major and minor malls in America and in Canada, and let's just go spend some manual time curating all those data, so that we've essentially hand drawn accurate polygons for all those malls, and then we have steps sort of in our pipeline when we're processing data to try to detect, okay, I know that this particular business is located, at this particular point. Is that point inside one of our malls that we've gone and drawn and curated? And if it is, then that's probably the case that POI belongs to that mall. And so we have sort of true geospatial sort of approaches to try to understand those relationships as well. And then sort of a final thing that we've also done is that all of these malls, almost all malls, especially major malls, they have their own webpage, and they have their own sort of directory listing of places. And if you're lucky, often they even will have maps of those places inside their mall. And so we've also done a lot of work to try to capture that information from all those mall websites and reproduce that in a way that's sort of easy to use inside our data set so that we have the best picture we can have about what are malls, what are not malls, and if it is a mall, what's going on inside that mall, where are these businesses located, and what are those businesses?
One of the reasons why I wanted to give you the opportunity to sort of clarify that and put some more words around it was because I think this must be very critical for a lot of these use cases, is having those accurate polygons. If I'm a business and I'm looking to let's say, advertise to people based on their location, then I don't want to do it just based on a proximity to a centroid. I want to know that they're actually inside the business. I can see that being a really critical piece of these use cases. So I was just interested to hear about how you solve those problems, and what I would think is quite a difficult situation with objects inside objects.
Yeah, it is an interesting challenge, and there's also interesting challenges sort of on the end user as well, right? Because if you want to take safegraph polygons and combine it with, for example, anonymized GPS data from smartphones, you're also going to be running up against limits to the GPS technology. And as I think intuitively we know that when you go inside a big indoor mall, your GPS data on your smartphone is going to get a little noisier. It's going to be harder to pinpoint that location. And so I think there are and there's a variety of sort of efforts around this to try to improve that with things like beacons and Wi-Fi signaling and things like that. If you connect to the Wi-Fi in a store, maybe that gives you some information about where that device is, things like that. But our end users are sort of fighting this from two ends, right? We're trying to make the polygons at Safegraph. We're trying to make the polygons as accurate as we can to help those end users with those problems. And similarly, the smartphones are trying to make GPS as accurate as possible and solve these sort of indoor location problems. But indoor location is sort of a different beast. And in general, I think the Safegraph data set has been designed and built towards the sort of GPS style data, which is more sort of for understanding these macro things. Once are you going into a building or not, but not once you're inside the mall, which store did you go to?
But it sounds like you'll be ready for that when that comes, when we get that accuracy in our cell phones, for example, when we can accurately map inside or geolocate inside buildings easily and intuitively, and it just happens behind the scenes. It sounds like your data will be ready for that. Is that correct? Or is there like other sort of data cleanup, data maintenance that needs to be done, but before you could really take advantage of that?
No, I think that's right. I think that's definitely our goal is to have accurate data at that level. And I think one thing that'll be interesting to see is exactly how those technologies sort of come around, because that might dictate different strategies for what we should do at Safegraph to make the product more useful. So if it just turns out to be some sort of accurate GPS or super hyper accurate coordinates inside locations, then Safegraph's well positioned already to serve those needs. If we end up using other types of signals, then Safegraph might want to look to try to add other types of attributes to the data set. For example, like something we've thought about in the past is, should we try to understand what the different IP addresses are for these different businesses? Because if you go into a store and connect to their Wi-Fi, maybe the end user advertiser would have access to sort of anonymized internet traffic data, but they wouldn't necessarily know the GPS coordinate. And so, if you have that information, how do you join that to something like Safegraph data to make it useful? So there's like product things like that we've thought about that we potentially could do in the future.
I guess this is a really good point in the conversation to start talking about the future. So, what are your plans? What kind of rows and columns or are you considering adding to your database, or is it just enough the way it is?
Yeah, great question. We're always thinking about how we can add rows and columns to the database, and that is definitely sort of the two ways we think about it, right? When we think about adding more rows, we think about what are the places that we want to catalog and report on that we aren't already. And we think about columns, it's what are the attributes we want to add to these places. And so we think about both of those as sort of our long-term product strategy. I think the big picture vision for Safegraph is we want to be the definitive place to go to get information about every physical place in the world. And that's a big task, that's a big challenge, and there's a lot of steps to go from there, from where we are now to get there. And as I mentioned, we sort of have started by focusing on places in the United States and Canada where consumers go and consumers spend money. And we think we have a pretty good handle on those places. So, today the data set's about 6 million points of interest. So we have, 6 million rows. And we think we're doing a pretty good job of capturing not only sort of the major retail brands like Walmart and Starbucks and things like that, but also the small businesses and the single businesses, individually owned restaurants or individually owned convenience stores or things like that. So we feel good about that. Now, in terms of the types of attributes we want to add to those places, we're thinking a lot about what are other dimensions of sort of consumer behavior that would be interesting for our end users to work with, right? So from our in our patterns data set, we have summaries about things like what times of day people are going to the stores and how those people are traveling to get to that store in aggregate. And you can also tie demographic data to that based on census data, right? So one of the things that we report in the data set is, on average, what are the different census block groups that people are coming from to visit the store? And again, we don't have any individual data about any of these individual devices. It's that's fully anonymized and then aggregated when we get it. But we can attach demographic data to those census block groups on average and say, for example, people going to this particular Starbucks on average are coming from these census block groups that on average have these types of demographics. And so that's also pretty interesting. There's other types of things that we've thought about doing. For example, can we get more data about sort of transaction level things that are happening at that store? Is there ways that we can understand, do people make lots of small purchases at this place? Do people make fewer big purchases? Things like that also would be interesting to our clients to add.
I guess if you, and this is just an assumption on my side here, but I'm imagining anyway that if you were looking to add more things to the database, you'd be looking at like what is the industry asking for, what can we provide, and what can we repeat. Is there any sort of weighting on those three categories, if at all you can split them up like that? That's more. Is there any one of them that's more important than the other?
No, I mean that's definitely the way we think about it, and I think we care about all three of those dimensions. I think the most important thing that drives our thinking is this a product that, if we made it and we did a good job with it, would people actually want it, and would our clients use it? And so we have a number of really outstanding customers that give us a lot of great feedback, and if we have ideas or if we're thinking about exploring new ideas, we'll go talk to them and ask them, if we were able to provide this type of data, is that something you would want to use? Yes. Okay. So if we structured it this way, would that be useful, or would you rather have it structured this way? It's important to understand that since we're really just a data company, right? We don't build solutions for people. We don't build sort of analytics services. We're really just building a data set that our end users take to build cool things with. And so we want to make that data both useful and valuable, but also easy to work with and generalizable enough so that different types of customers will all be able to use it and run with it. So yeah, I think those factors all affect the strategy a lot.
So I feel like we've talked just a little bit about this before, but we've never approached the topic directly. What are the really big opportunities that you see in this space in the future?
Yeah, that's a great question. So, I mean, I think that in general, there's a couple big trends happening right now that are going to be exciting for the future. The first is like a general macro trend around data science and machine learning, which is that as data is becoming more and more easy to collect, easy to store, and easy to work with, right? Compute's getting cheaper and cheaper. We've seen this explosion of machine learning, artificial intelligence applications, and I think that's going to continue, and that's very exciting. I think that's also then sort of intersects with the GIS world, where I think that as companies in general are getting better at working with data in general, I think companies are starting to realize more and more that there's this whole rich GIS world that exists to help them think about location. And I think that we are going to continue to see more and more GIS users in the future. And I think that in some ways, like GIS sort of is this interesting niche within data science, but I think in the future, it's going to become a much more generalizable, it's going to be, or rather, I should say, it's going to be much more integrated with the rest of data science, because the tools are getting so good, the needs are becoming so much more clear, right? Location and GIS can be a part of almost any type of retail or marketing or supply chain logistics. Like so many things in the real world are location context dependent. So I think that to me, what's really exciting is to see these different sort of niches of data science being more integrated and coming together more so that, whereas in the past, maybe someone was a specialist in NLP or GIS, in the future, I think these things, we're going to have tools to make these things much more integrated. And that's just going to mean more and more people using GIS and understanding how powerful GIS can be.
You said it yourself a lot of times there. You talked about people using GIS, and that's exactly the way I think of it. When I think of GIS, I think of a person sitting there doing some kind of spatial analysis or working with geographical data. But I think right at the start, at the top of the interview, we talked about this being a truth set of the physical world. So getting back to that idea, um, I think what we're talking about there is a truth set also, of course, for people as well, a set of data that they can use, but also for machines. So if we have a way of validating what machines are doing, are they doing it correctly? Can we hold it up against the truth set and say, yes, 80%, 90% is correct? And I think that's a whole different way of thinking about GIS and geospatial in general. So yeah, we're making data for people, but we're also doing it for machines.
I think, yeah, I think that's right. And I think there's an interesting dynamic sort of in this regard in the GIS world. And again, I'm relatively new to the GIS world. I've only been really working in the last, three and a half years or so. But I think, and you can tell me what you think, Daniel, if this is like the right impression. But I think that in the past, especially going way back, but in general, I think people that worked in GIS, if you made maps, if you were a mapping person, that was often very synonymous with collecting and generating the data yourself, right? Like to make
Yeah,
the
yeah,
map, you had to go out and get the data about the map. And often when we talk to people who work in GIS, especially these people that have been working in GIS in a long time, sometimes they're a little confused about our value proposition because we're saying, SafeGraph is saying, hey, like our value proposition is we've gone out and done all this work to get this data together so that you can just take it and make maps and build applications and answer questions. And sometimes people are thinking, well, I thought my job was to get the data. So I think it'll be interesting to see, we think that there's enough resources now where you can sort of segment these different types of skills. And in some ways, I think they are different types of skill sets, right? And the whole idea is that Safegraph thinks that we can focus just on doing this hard thing of getting the data together, and you can focus on what you do best, which is GIS analytics and analysis and making maps that tell good stories and communicate effectively. And I think that's like a really exciting version of the future.
absolutely. And I would agree 100% with what you said there. And I think in the same way, we see companies like yours, like Safegraph, saying, hey, we're not a jack of all trades. We do this one thing, but we do it really, really well. And I think you used the word segmenting before. And I think that's a great way of thinking about it. That we're very targeted. We're doing this one thing and we're amazing at it. And I think in terms of GIS or geospatial, at least my impression of the industry up until now has been that the typical GIS person has been that jack of all trades. They've been doing a lot of different things and never really had the opportunity to focus on one thing in particular. And I think it's difficult to find a person who is a really good spatial programmer at the same time understands the IT infrastructure and can produce incredible cartographic output. But that has been the expectations in the past anyway. So I think there's a real shift happening now where people are saying, okay, well, we need specialists in these areas here.
Yeah, I think that's right, and I think it's it's the same sort of trend that I think that you see in the broader technology world, where in the beginning, Internet 2.0, you had people that were sort of full stack engineers that would do everything from the infrastructure and managing the hardware all the way to building the web apps. And as that technology has grown, and as we've had companies that offer services to help sort of segment and compartmentalize those different skills, we've also been able to have people sort of focus their expertise on different parts of that value chain. And ultimately, that just lets people double down on what they do best and what they enjoy the most. And I think that's a good thing.
Yeah, I agree, but I think it's always interesting to see or to hear if people understand this as an opportunity or like a setback. So
Hmm.
but that's just me personally. I find it really interesting how people approach this new what I would call an opportunity anyway. Hey Ryan, It's been an absolute pleasure talking to you. I've really enjoyed the conversation, but I can see that we're running out of time now. But before I let you go, I just want to hear where we can go to learn more about you and follow along with the company.
Oh, definitely. It's been great talking with you, Daniel. If you want to learn more about SafeGraph, we have a couple great resources on our webpage, safegraph.com, that links to our blog. We do a lot of writing about our data use cases and things you can do with our data. So if you're interested to learn more about that, I definitely encourage you to check that out. We also have the SafeGraph data bar. If you want to try some of the SafeGraph data yourself, you can go there. No credit card needed. You can download some data. I think we're going to offer a coupon code with the code MAPscaping. Gives you $500 worth of free data from our shop. If you want to just download some of the data and play with it, you're strongly encouraged to do that. We also have SafeGraph is on Twitter at SafeGraph. If you like the space, I definitely encourage you to follow our CEO and founder, Oren Hoffman, on Twitter at AUREN, Oren. And you can also follow me. I'm on Quora and on Twitter at Ryan Fox Squire.
Thanks very much, Ryan. I'll make sure to put these links in the show notes so people can follow up there if they like, or on our website. And I just want to say to the listeners out there, I've been to the data bar. I've tried it out. It's amazing. It's not often I get really excited about this kind of data, but I have to say it's structured in a really beautiful way. It was really intuitive, easy to find my way around, and to see what I was getting. I was deeply impressed.
Oh, thank you so much. Great to hear that.
Thanks again. Really appreciate your time.
Thank you.
So I just want to mention that with data again, if you are interested in trying out this data set for yourself, SafeGraph is offering $500 of free data every time you use the coupon code of Mapscaping. So if you go along to shop.safegraph.com or search for SafeGraph Data Bar, you can get access to this data. No questions asked, no strings attached. Try it out. And if you do try it out and make an interesting map, we'd love to see it. So feel free to tag us on social media. It'd be awesome to see this data in the wild. So at the top of this interview, I talked a little bit about my sponsor, HiveMapper, and I mentioned about how you can upload video footage to the cloud and have it processed to 3D mapping layers. But what I didn't mention is that they've got this really cool feature that also lets you segment images, and this is done automatically. So there's no training sets required, there's no pixel signatures required, and it's repeatable. So I could do this for every single layer that HiveMapper creates for me, and I can automatically segment images into show me all the buildings, show me all the trees, show me all the water, where is the pavements. And they have another really cool group there, which is called mobile, and this is all the things that can be moved, such as vehicles, boats, cars, aeroplanes, people, and animals. I have no clue how they do it, but I think it's cool. It's worth checking out. And that's it for another episode of the Mapscaping podcast. My name is Daniel, and I want to remind you that you are more than welcome to reach out to me for whatever reason on social media. To do so, you'll find some useful links in the show notes of this episode. I would really love to hear from you. Thanks for listening. It's much appreciated, and I'll see you next week. Bye.